So today we are going to be delivering an oat disease webinar. My name is Cindy Webster and I'm hosting the webinar today, and my colleague Jeanette Pratt is co-hosting behind the scenes. So moving on to today's agenda, we have DPIRD research scientist Jeff Thomas talking about the newly detected disease red leather leaf. And then we'll be moving on to Dr. Kylie Chambers, also a DPIRD research scientist. He'll be talking about crown or leaf rust in oats, latest research findings and the impact this disease has on hay and grain yield and quality. We will be having a Q&A session at the end of the webinar, so please feel free to type any questions or comments in the Q&A tool down the bottom of the screen, and then we'll read them out and our presenters will answer them just to keep the presentation flowing. We will be publishing this webinar recording on the DPIRD YouTube channel shortly, and we'll also circulate the PowerPoint slides and have them available for viewing afterwards. And before I hand over to Jeff, I'd just like to make everyone aware that we will be keeping attendees' microphones muted just to try and increase the sound quality of the webinar today. And that is it. And I will hand over to Jeff. Thank you, Jeff.
Thanks, Cindy, and welcome along everybody to the webinar. As Cindy said, I'm going to be talking about red leather leaf of oats, which is obviously a newly confirmed disease here in WA. As I said, it's a new disease, and so there's not necessarily a lot of West Australian information available about this disease. So I will be relying on information and resources from colleagues, pathology colleagues in Eastern Australia, where this disease has been present for some time. And particularly I'll be relying on information from Agriculture Victoria colleagues, Mark McLean and Hari Dadu. So before we move into red leather leaf, maybe we just have a quick look at what are the major diseases of oats in WA. So as part of the AgriFutures National Hay Agronomy Project, over the last 3 years, we've been surveying hay paddocks for the presence of diseases, and you really wouldn't have to be Sherlock Holmes to work out that Septoria blotch is probably the most common disease in oats in Western Australia, and over that 3-year period, about 90% of paddocks surveyed had this disease in them. And obviously those higher rainfall, higher oat inclusion areas are the areas where Septoria was most severe and most impactful. Bacterial blight, stripe blight, is commonly found. So about 40% of paddocks had that disease, but really the in-paddock incidence and the severity of that disease is relatively low. So whilst it's relatively common, particularly in Bannister paddocks, it's probably not that impactful in each paddock. Rusts, and so leaf rust particularly, but leaf and stem rust, and Kylie will be talking more about the leaf rust particularly after me. If you look at that, if you look at the table, you can see that we have been detecting rust, but as you know, leaf rust, rusts can be quite sporadic and dependent on seasonal conditions, varieties, what pathotype is present. And so over the 3 years, really the 2021 season, where we had a bit of a green bridge, and certainly wild oats had significant amounts of leaf rust, and we saw that reflected in crops. But what we're talking about today is red leather leaf. And as I said, red leather leaf was detected and confirmed in WA crops for the first time last year. So let's start out, what is red leather leaf? So straight off the bat, it's a foliar disease of oats caused by the necrotrophic fungus Neospermospora avenae. So it's a necrotrophic fungal disease. It was first confirmed. The first confirmed record of red leather leaf in WA came from samples in the 2021 season. In fact, that confirmation happened earlier this year. It takes a little while for that fungus. It's a bit hard to isolate and to work with, and then a number of processes, including molecular confirmation, needed to happen. But samples from the 2021 season came back as positive with this disease. We've had a number of unconfirmed anecdotal reports over the last few years, which certainly indicated that there was a risk of this disease now being present, and that was confirmed last year. So we had 3 positive samples last year from that sort of Pingelly down to south of Narrogin region. That spread of disease certainly suggests that the disease has been present for a little while in WA. Whilst this was a new detection or confirmation in Western Australia, it's certainly not a new detection for Australia, and this disease has been present in southeastern Australia for quite some time, and quite a lot of information is available from our colleagues in those areas. So what about the biology of the disease? Well, it's hosted by both, it's an oat foliar disease, so it's hosted by both cultivated and wild oats. The primary inoculum source is either seed or stubble. Seed is probably the way that it arrived here in WA sometime in the past. Once it becomes resident, then obviously that stubble-borne phase becomes the primary source of inoculum, much like we might see with Septoria. In the spread within the crop, the secondary spread comes about by the presence of spores in those lesions, which are then spread by splash and wind from infected leaves into other parts of the plant. In terms of, it's favoured by cool and wet weather, so sort of 5 to 16, 15, 16 degrees and wet conditions. So in a WA sense, that's probably this, our winter and early spring conditions particularly favourable. And I guess the infection and potential for loss is generally greater in those cooler, high rainfall regions. And so without having done any great epidemiological modelling, that would suggest that maybe that sort of western oat production region of the Kwinana South and Albany port zones are likely to be suitable for this disease, and particularly in areas where there's a bit of oat, an amount of oats being produced, and so an amount of stubble around. What I would suggest is that probably our eastern medium rainfall zone and lower rainfall zones of WA are less likely to be suitable for the disease. Maybe not that it won't necessarily occur occasionally, but much like diseases like Septoria, whilst they're present, probably only less than likely to cause significant problems. And certainly, again, like Septoria, dry springs should limit that upper canopy development. So in years where the spring dries off, this disease is probably not going to be favoured. So what about symptoms? So what should we be looking for? So it's a fungal disease. It starts as individual lesions with a lighter centre, depending on what you read. There's any number of descriptions, but a lighter centre might be a grey colour, might be a bluey colour, with a dark red-brown edge. So, a fungal lesion. The symptoms then develop into sort of red, irregular shaped lesions, which can spread across or along the leaf. And then as the leaf ages, the affected leaves take on that sort of leathery appearance with a red-brown colour, hence the name red leatherleaf. So what we're seeing, as with other necrotrophic diseases, is that they are stealing photosynthetic area from the plant. What it can be confused with? Bacterial stripe blight, Septoria blotch or Pyrenophora blotch, those fungal diseases as well. But the other one that I personally and others within DPIRD diagnostics have had experience with is people bringing in plants with red coloured leaves, particularly at the base, but without any of those fungal symptoms. And as we know, oats tend to go red pretty easily. So abiotic, nutritional, physiological reddening can be confused with red leatherleaf, and certainly in the past in Western Australia has been confused with red leatherleaf, but hasn't been red leatherleaf. That photo on the right is a classic example of a canopy with red leatherleaf. This is a great slide from our colleague Hari Dadu in Agriculture Victoria, and just shows this progression of symptoms of the disease from an uninfected leaf on the left through to a red leatherleaf on the right. But you can see those progression from individual lesions to larger lesions with that grey coloured centre, with the reddening around them spreading through the leaf, and then that red leatherleaf at the end. A couple more pictures from our Victorian friends. On the left, we see a plant at that sort of tillering stage with, again, those lesions with that reddening around it, and then obviously a canopy photo with those lower leaves being impacted. Bit of WA flavour. So these are photos from one of those samples where we have managed to extract neospermosperous spores. So these are obviously those early lesion components of that disease cycle, individual lesions. And when we moist incubated these leaves in the laboratory and looked for spores, we were able to identify neospermosperous spores from these samples, and these are WA leaves. So why are we talking about it? Apart from the fact that it's new, well, here I'm really relying on the information generated by Agriculture Victoria Friends in a similar survey that they conducted as part of that AgriFutures National Hay Agronomy Project. Red leather left was the most common and severe disease of hay oats in that southern Victorian HRZ MRZ region during that time, much like Septoria was for us. It was in about 60 to 90% of crops annually, and was most severe when there was average and above average rainfall in that winter and early spring conditions, and certainly most significant when we were adjacent to or over oat and stubble. So it's pretty common in that southern Victorian region, and then trials carried out by Agriculture Victoria and others have indicated that it can, in susceptible varieties in favourable environments, when disease becomes apparent, during that winter period, can cause significant grain and hay yield losses. Trials have shown reductions of up to 15 to 16% in grain yield. I mean, that's the upper measurement, and certainly, maybe around that 5 to 12%, but certainly in susceptible varieties when disease is present, significant grain yield losses can occur. In hay trials, biomass losses, again, in those most severe conditions, of up to about 20% of reduction in biomass. Probably, again, more commonly in that sort of 10 to 12%, but again, significant losses in hay biomass, reductions in plant height and in stem thickness, visual impacts on hay quality through the reddening, but interestingly, not as much impact on hay nutritional qualities, but certainly susceptible varieties, favourable environment, disease present from that winter time, significant grain and hay losses can occur. In terms of varieties, now this is from the NVT online site. Obviously, we don't have any WA screening, having just confirmed this disease. These are from the national NVT rating site. But a couple of things to point out. Again, the trials in the eastern states have indicated that those susceptible and very susceptible varieties are the most at risk. Once we get up to MS or better, we're starting to see a reduction in the risk associated with yield loss. There can be variations in the response depending on the phenology of the variety and how much exposure there is to those favourable conditions, the seasonal conditions themselves, and probably even some regional differences in response, maybe in terms of the virulence of the disease. But certainly, when we look at that table there's a suggestion that the majority of varieties are in that susceptible to very susceptible range, and certainly monitoring for this disease when we know where it's occurring and if it's going to be problematic in Western Australia will be important. So I guess in summary, what are the risk factors and what are the management approaches? It's a stubble-borne disease. Stubble's the primary source. So crop rotation is obviously a major plank in any integrated disease management approach. Proximity to stubble increases risk, and particularly risk of early infection in that winter period, much like we would, so similar to, say, something like Septoria and oats, rotation is a good management approach. I've spoken about variety resistance, sort of moderate susceptibility and better, certainly reduces the risk, but does it impact yield and quality impacts can occur in those S and BS varieties. In terms of seasonal weather, it's a cool, wet season disease. So higher rainfall environments, in those cooler, higher rainfall environments, we certainly would expect this, or we would certainly think that this disease may be a risk. Dry regions, dry seasons, hot, dry finishes to the season will probably limit the impact, as it does with a disease like Septoria. always get asked about fungicides. Currently, there's only one product with a registration for red leatherleaf, that's Top Notch, which has a suppression claim. But what we do know, and from a number of trials carried out in Eastern Australia, is that the fungicides that we're already using in oats for managing other diseases such as septoria or rusts can reduce the severity and impact of this disease. So an active ingredient like propiconazole can certainly have some impact on disease development and yield loss. Where the disease is present, so let's say we're cropping oats over oats or directly adjacent to oats, and the disease gets going early in the crop, then trial work from Ag Victoria has certainly shown that early intervention, so tillering to stem extension, has been shown to be very, very effective. I think there's probably a couple of factors to that. One is it gets in when the disease is getting going in the conditions, those cool and wet conditions of winter into early spring, or in winter, but really, where the disease is most favoured. So that getting in front of or with the disease development has been shown to be effective. Finally, what are we doing this year? As I said, we've detected the disease in that sort of Kwinana South, the western portion of the Kwinana South zone, where quite a bit of oats are growing. We're going to be looking for the disease this year as part of our GRDC DPIRD surveillance project, disease surveillance project. And so we're particularly interested in getting an idea of how common it is, maybe how much disease is out there and how bad it is. So we're interested in getting samples. We're interested in seeing crops that have suspected red leatherleaf this year. I would certainly encourage people to contact Kylie or myself or your local DPIRD pathologist if you're worried about the disease, if you need more information, or if you have samples. We are certainly interested to be receiving those samples as part of our surveillance project this year. And as I said, trying to get an idea of how bad the disease might be in WA and where it might be occurring. I'm happy to take questions following Kylie's presentation, but for the moment, that's the discussion on red leatherleaf. Thank you.
Hi there, I'm Kylie. As Jeff mentioned before, there are two main oat rusts that we get here in WA. So we've got the leaf rust here on the left and stem rust over here on the right. We also have, so it's really important to actually note the differences between these two different oat rusts. So with leaf rust, as you can see, it's more of a yellowy orange colour, and with the stem rust, it is a darker reddy brown colour. And as their name suggests, the leaf rust is generally found on the leaf, while stem rust is generally found on the stem of the plant. However, both rusts can be found on all the areas of the plant tissue, basically. So today we're mainly focusing on leaf rust, which last year we found in around 50% of the crops that we surveyed. So to manage leaf rust, we've got a few different options. We've got variety choice. So genetic resistance is the most effective method for reducing risk and the impact of leaf rust. So by avoiding sowing susceptible and very susceptible varieties in high risk environments, that's our best management option. We've also got fungicide application. So we've got numerous fungicides available for the control of leaf rust, and it's important to apply these fungicides early in the infection process to stop that infection building up, because rusts can multiply quite quickly. We've also can manage the green bridge. So leaf rust can survive on green leaf tissue and is able to grow on wild oats. So over summer, this disease can still survive on those wild oats, and then in the next season, reinfect your crop early on. And that also leads us to monitoring crops. So monitoring crops is also quite important so that you can see when this disease is actually starting to take a hold, so you can make a choice on whether or not you need to apply a fungicide. We've done some work with AgriFutures as part of the National Hay Agronomy Project, And we have a disease management guide coming out shortly on the management of oat leaf rust and stem rust, which we will link to once that's available. So with leaf rust, we've got varieties here, and you can see that we've got a variety of different susceptibility and resistance to this disease. But also, as you can see, carrolup is very susceptible to this disease. However, a large percentage of our oat growing area is actually sown to carrolup. So we still have a very high potential of getting leaf rust in crops when the conditions are conducive for disease development. As part of that National Hay Agronomy project, we ran field trials in 2020 and 2021 to have a look at a few of these disease management strategies. So we had 3 different fungicide strategies: a nil, a single application at flagleaf, and a multiple application, which should have been a full disease control. In 2020, we had the susceptible variety carrolup and moderately resistant varieties Mulgara and Williams. Whereas in 2021, we had Winteroo, which is susceptible to very susceptible, Williams, which is moderately resistant, and Coorabut, which is moderately resistant to moderately susceptible. As you can see here, genetic resistance really is key. With Mulgara, which is moderately resistant, you can see that there's no disease present on those leaves, whereas with carrolup, you can see disease development of leaf rust quite early on in the season. And at the end of the season, so this is at when we're cutting for hay, you could see how prevalent disease is in carrolup. So that top left-hand image there is carrolup with no fungicide application, and you can see that that leaf tissue is almost completely taken up with leaf rust pustules. And you can see underneath that in image C, even with a full disease control, which was 3 fungicide applications in season, you can still see leaf rust pustules on that leaf tissue, just not as bad as the nil. And then on the right, we can see what genetic resistance can do. So Mulgara is moderately resistant. And as you can see in the nil plots, we had very little rust present, and then in our full disease control, it basically looks the same as our nil, which really highlights how much genetic resistance can actually protect your plants against leaf rust. At the end of the season, we also cut the oats for hay, and as you can see here, leaf rust significantly impacted yield. So in our first year, carrolup had a 20% reduction in yield, whereas Winteroo had a 40% reduction in yield in 2021. And this is of the hay yield. We also had a look at the hay quality. And as you can see here, I've just got up our 2020 results, that the nutritional quality of our hay was significantly impacted by leaf rust, especially in carrolup. So you can see here that we've got several nutritional parameters which are significantly impacted. So we've got the acid detergent fibre, the neutral detergent fibre, the dry matter digestibility, and the water-soluble carbohydrates, all significantly impacted. And this has also caused our hay to go from really high quality export hay, so grade 1, to a really terrible quality hay to below a grade 4 with the carrolup. Which is quite significant. With hay, nutritional quality isn't the only thing that is important for exporters. So the visual quality or the greenness of hay is also quite important. So we also had a look at the greenness of that hay. So as you can see with Williams, which is moderately resistant, when we have a look at that top row of hay, all 3 of those milled samples look quite similar in colour, regardless of the fungicide management strategy. Whereas when you have a look at Winteroo, which is the bottom 3 samples, you can see the bottom left sample, which has no fungicide application, is a duller browner colour compared to the other 2 samples. So the middle sample on the bottom and the bottom right sample, which is a bit greener and brighter. than that nil sample there. So even though that difference looks quite subtle to our eye, we can actually measure this using a few different methods. So we had a look at the red-green colour spectrum and also the chlorophyll content of those samples. And even these other methods could also pick up that difference in coloration. So not only do we have a nutritional quality difference, we've also got a visual quality difference as well. Moving on to the grain impacts, in both 2020 and 2021, we had a 48% grain decrease between our nil and our full disease control. So you can see here that leaf rust can really have a significant impact on grain yield, because that is, almost 50% of your crop yield just gone. And on top of that, we've also found that we also had a decreased grain quality. So we had a decreased grain weight and increased screenings. And with Carola, we had an increase of 8 times the amount of screenings between our full disease control and our nil, which is quite significant. So what are the conclusions from all of this? That leaf rust can significantly impact hay grain and yield quality. That in high risk areas, sowing more resistant varieties is key. And in these high risk environments, more than one fungicide application may be required for premium hay or grain quality in susceptible varieties such as Carola. And rusts multiply quite quickly. So applying fungicides early in the disease establishment is essential for disease control. As Jeff mentioned earlier, we're after red leather leaf samples or suspected red leather leaf samples. So if you think that you have that in your paddock, please feel free to contact us. Here are our contact details. And I'd like to thank everybody that has been part of the research as part of the leaf rust work, as well as that red leather leaf work that Jeff has spoken about previously. Thank you.
Fantastic. Thank you very much, Carly and Jeff, for your presentation. And that brings us to the Q&A part of the webinar. And we have had a couple of questions come in. At the moment, that do relate to red leather leaf, but feel free, attendees, to add questions as you think as we go along. So our first question, Jeff, if you'd like to answer, is walking through the red leather leaf affected crops, will it stain clothes?
So that's a good question, I guess. So no, the red colour is not something that rubs off. It's the actual oat leaf itself goes red and becomes necrotic. So no, walking through you won't get red. But if we just move on to what Kylie's talked about, if you were to happen to walk through a oat leaf infected paddock, then yes, your pants would go red from the oat leaf rust spores, which are on top of the plant. But no, that red colour is sort of a discoloration within the oat leaf. And as I said, much like some other factors which can also turn oats red.
Thanks, Jeff. And our second question, is there an initial symptom that distinguishes red leather leaf from other diseases such as septoria and bacterial blight? So
first of all, I've got to remind you that I've only seen it a little bit in Western Australia, so I'm not the world's greatest diagnostic expert at this point. But I would say that the lesions that I have seen on leaves have been of septoria, tend to be a darker, often with a sort of a purpley dark colour, whereas these red leather leaf ones that I have been seen had a more of a whiter or lighter interior with a dark margin. So they are slightly different looking. In terms of bacterial blight, and certainly I've seen information from our colleague Hari Dadu talking about the fact that bacterial blight and red leather leaf do get confused on some occasions, but I guess often stripe blight or bacterial stripe blight will appear as sort of longitudinal stripes quite often on the leaf, which then develop into a collapse into a sort of a blotched type area. So I think early on there's probably able to see some differences, but I think as they create the blotches, there is opportunity to be confused. but for both of them, we would expect the much like other diseases, that we would see a progression of the disease up the canopy, from lower leaves up to higher leaves, and a grade of severity up the canopy. So yeah.
Thanks, Jeff. And as you mentioned earlier, you are happy to receive samples, and that will be free of charge to the agronomists and growers for the sample to be confirmed as being leather leaf or not?
Yes. Yes. So as part of our diagnostic approach at the moment, obviously we're pretty interested to know where it is and what it's doing. So certainly if people think that they might have some red leather leaf, then we're certainly interested in receiving those samples as part of our diagnostics and surveillance project.
Thank you. And so we don't have any questions at the moment, but you do have our presenters' contact details. Feel free to contact Carly or Jeff if you have any more questions. And we will be putting the recording on the DPIRD YouTube channel and circulating these PowerPoint slides. And that brings us to the end of our webinar. We'd like to say a very big thank you to all our attendees for attending today. Thank you to Carly and Jeff for taking the time to present to us on these really interesting topics. And thank you, Jeanette, for co-hosting behind the scenes with me. And we'll say goodbye for now. And we hope everyone has a great rest of your day. Thank you. Bye.